Before we move on from this question, I actually want to show you another way of approaching it. And you might even find this way, you might actually like this way more than what we just went through. So let's just divide this up and let's go option 2. So this is another way of doing it. So it's another way of approaching this question. And it's really thinking about triangles more so than the first one. So we're going to begin by drawing ourselves a right angled triangle. Here is theta. I've been told that sine of theta is equal to 3 on 5. I know that sine is opposite over hypotenuse. So that means opposite would be 3 and my hypotenuse would be 5. What I'm going to figure out now is what this x would be. Okay, so how can I figure that out? Well, we can just use our Pythagoras to figure this out. So I know that x squared is equal to 5 squared minus 3 squared. X squared is going to be equal to 25 minus 9. X squared is going to be equal to 16. I would then square root both sides, which means x is going to be equal to 4. Now, you need to determine whether or not this is going to be plus or minus 4, because remember, when you square root a number, you have to consider whether it's plus or minus 4. And this is the same logic as we used in the first part in figuring out that cos is negative because I'm in my second quadrant. So x is going to be equal to negative 4 because cos is neg in quad 2. So you still need to know that. Once we've done that now, but I can draw my triangle again. I know that this is 3, this is 5, this right here was my theta angle, and this was negative 4. Remember, this is a right angle triangle. As you can see, sine of theta is equal to opposite over hypotenuse, 3 on 5. Cos of theta is going to be adjacent over hypotenuse, so negative 4 on 5. So negative 4 on 5. Tan of theta is going to be opposite over adjacent. Opposite adjacent will be negative 3 on 4. So there are all our answers. And that's what we got in the first part. We got this as our answer, and we got this as our answer. So that is another way of approaching this question. So let's just kind of zoom out here and see everything that we've done. You can do it this way. This is like strictly using your Pythagorean identity, or you can do it this way, in which you're using your knowledge of Pythagoras. And yeah, people find this way helpful as well. Either way you do it, you still need to go about finding whether or not you're positive or negative, which is considering your domain. So you still have to use this in doing it. So, but some people like doing it this way. It's a useful way to do it. Hopefully you found this useful.